Hey guys, it's Jim Vanosky with Manufacturing Talks. You've probably heard of Siemens, big name out there. And Siemens Digital Industries is all about industrial automation. They do both software and hardware. And, they've been working with the big guys for years. But if you're a small and medium manufacturer, maybe that name kind of scares you. Well, I'm here to share a couple things with you. Number one, they've got some amazing stuff going on in digitalization of manufacturing. Number two, they're focused on small and medium manufacturers now and helping you guys along. So, number one is something everyone needs to learn. Don't matter if you're big or small, you need to be getting on this stuff. But number two is crucial because as Cedrik Neike, who joins us today, says, if you're a small and medium manufacturer and you're not focused on digitalization, you're going to slowly fade away. So tune into Manufacturing Talks here and hear all about it from Cedrik.
Welcome to Manufacturing Talks with Jim Vanosky. Industry has a million cool stories, and Jim talks to the movers and shakers who are making them happen. Let's dive in.
Welcome to Manufacturing Talks. I'm Jim Vanosky, your host, and we are sponsored by DYS Media. You'll hear from them about halfway through our show. And I'm pleased today to be joined by Cedrik Neike. He is our CEO of Siemens Digital Industries. Welcome, Cedrik.
Hi, Jim. Good to be here.
It's great to have you on. We actually go back a ways. I wrote something about you guys back, a couple of years ago. And you got some news coming out, so we want to talk about that. But before we do, why don't you just tell our audience more about what you do and then more about Siemens, which is, obviously a huge topic.
Yeah. So Siemens is the biggest technology group in Europe. And we're a global group, 175 years old. But fundamentally, I'm one of the five board members running Siemens, and I'm in charge of the digital industry part, which fits the discussion we're having today. And what you might or might not know is we're the biggest industrial software company in the world. We're one of the 10 biggest software companies there. So we use a lot of software when you design things, but we're also on the automation side, actually making things. We basically have the PLCs, the brains of most of the machine. Every third machine in the world has a Siemens brain. So we actually are in the IT world and in the OT world of making things happen.
And that's a phenomenal introduction. And then we're here specifically to talk about some new offerings you've got. And I love that you mentioned the brains of, those of us in manufacturing, what we do, the PLCs, we're all pretty familiar with that. I think where we'll find people kind of wanting to learn is, everyone's familiar with that kind of shop floor automation, but there's so much hype now about Industry 4.0 and connectivity and, there's I think a lot of people out there kind of wondering, okay, what is this all about? And how much do I need to be jumping into it if I don't already have that? Or how much do I need to be advancing what I have, that kind of thing. And so you guys have a new offering called Industrial Operations X, right?
Yes.
And so that's kind of the overview. Let's get into what that involves and then some of those things that people can look at where they might improve their own operations.
Yeah, and perhaps I'll go a step back to
okay.
put it in place. At the moment, I think Industry 4.0, which is one of the buzzwords in the industry, was launched more than 11 years ago at Hannover Messe. And I have a feeling that now Industry 4.0 is finally happening. It's a bit like hitting a ketchup bottle at the back. It's just now everything comes out at the same time. And the reasons are pretty clear. This is geopolitics. There's a lot of reshoring and nearshoring and friendshoring, which is happening. A lot of sustainability. We need to be more sustainable in the things we do. And of course, workforce shortages, right?
Right.
In the G7, 22 was the first year where more people are leaving the workforce than entering the workforce outside.
Right.
So, and that basically means we need more automation to be able to make that happen. And so just to tell you what we're going to launch at Hannover Messe is we've took all of the software we have and all of the automation and modularize it. So you can pick and place instead of building and buying a monolith. You're taking exactly microservices which you need on the hardware side, on the software side, and plugging them together. And that's what we do with what we call accelerator. And accelerator operations is the part in the OT world, which does it. And I can give you a couple of examples if you want.
Yeah, I definitely want to dig into that accelerator. I was reading about that. And to me, what you just said and what that represents is so powerful because there are so many people kind of struggling with how to get in and what part fits for them. And I think that modularity that you guys bring could be a huge kind of, I guess, prompt for people to understand where the biggest bang for the buck for their operation is going to be.
No, absolutely. And you can start at a certain part. You're not locked in, right? You might take a
Mhm.
Siemens element from somebody else, a competitor, and plug them together. You might be a small, medium company and you just can afford a couple of those elements. You might even take them out of the cloud. So this flexibility is super, super important. And what we're trying to do is to basically say, look, I mean, the world loves IT, right? Everybody speaks about IT and we have lots of IT capability, but it actually runs on OT, right? On operational technology. Anything you have, I mean, your cup, your books, everything is being produced running on OT. And we need to make sure that these two worlds sort of connect in a much, much better way. And this is what we do. So, for example, we said, look, we have this amazing PLC at the moment. Why not virtualize it? Why does it have to be a box which sits on the shop floor? Why couldn't somebody in this IT environment just take it, program it, distribute it wherever we wanted it to? So we're going to show basically the virtualization of the PLC. So making something out of the OT world also part of the IT world.
Amazing.
Another example is, for years and years, people have been trained to program production lines, very different languages.
Right.
A lot of you guys are coming and girls are coming out of the IT space. Let's give them modern Python type tools to be able to do it. So we're making those two worlds blur much more to have a big impact. And if you want, I can give you a couple of examples on how we do that.
Yeah, let's talk a little bit about that, because I also want to get into some of the other, I guess, technologies that can really help people out, stuff like digital twins. Before we do that, it just fascinates me, some of the stuff you're saying around really modernizing things that we're all familiar with. I mean, really now for decades, right? And bringing that into today's programming world, today's virtual world. So yeah, give us more detail on some of those offerings.
Yeah, I mean, the main idea is what we discovered is at the moment, the biggest issue you have is you don't find enough workers when you want to basically build a plant at the moment anywhere in the world. It's
Right.
very difficult to get those, and often the skills you need are extremely complicated and abstract. So what we said is why wouldn't we simplify the technology we have and make it more sort of common knowledge? So that's one of the key things we've worked on, is to say, look, let's simplify the way we program basically a production line.
Mm-hmm.
In order to do this, let's talk about the digital twin.
Mm-hmm.
I'll give you a concrete example. So we just won Daimler Truck, right? They're building trucks
Yep.
at the moment. So what would they do? They would use our software to design the truck. They would then use our software to be able to say, what are the different bill of materials I need? They would simulate the truck crashing or what happens when there's rain. But then they would use that data and says, look, what happened if I want to build this truck? So they would automatically take this truck and basically design the whole production line, people, robots, what needs to happen, how do they need to interact? And then they would build not only the digital twin of the product, which is what I described to you, but also the digital twin of the production. And then, and this is what we do with Accelerator X, the production would talk back to those twins and say, this is changing. So every truck you build will become better than the truck beforehand, because every mistake gets captured, gets put back into the design, you can optimize it and really sort of drive this. And this is what we're trying to do by virtualizing, simplifying, integrating the different OT pieces, which were up to now quite separate from the IT world.
So one of the other terms I saw referred to was industrial metaverse, and some of what you just said kind of sounds like it's headed in that direction. Is that accurate?
Yeah, and it's important to talk about industrial metaverse, because there's lots of words in metaverse and things which are happening. But
yes. Otherwise, you might have a marketing problem.
Exactly. Is that we start, and at Hannover Messe, for example, we're going to show this for battery production. So one of the biggest industries which are coming up at the moment is building batteries. I mean, I think there's $300 billion which are being invested in the next 3 to 5 years on building batteries, because you cannot build electric cars without batteries.
Right.
You cannot do the energy transition without batteries. But the problem with batteries, the manufacturing process is not ideal. So what we do is with a lot of those startups or companies, we actually in the metaverse build the battery and say, how does the battery look like? What needs to happen? But we also build these gigafactories, which will churn out those batteries at an amazing speed. And you can see it if you go to Hannover Messe, you will see really a hyper realistic representation of the battery and how it's being produced and how it's being planned. And you do it all in the metaverse before having even touched it for the first time. So by the time you build the factory, it is super efficient. It is using much less water, much less energy than something else. So you take the advantage of the metaverse to simulate, and then you take the advantage of being capable of producing it in the real world. And that's the type of things where the metaverse really helps. It helps you avoid wastage by simulating it completely in the digital world.
Well, and that hits on a couple of things. One is for, a crusty old manufacturing guy like me and all my peers out there who are watching, you just touched on something huge, and that is that modeling up front of the factory and the product together. I mean, I'm just thinking what that means for starting up a factory, which typically is a nightmare, right? And now you're saying you can digitally project all this stuff, problem solve, troubleshoot, do all those things that those first months of startup put you through hell to do, and you're doing it in advance in the metaverse.
And if you've been on a shop floor, if you've been a designer, you know what happens. You have an S plan and you have an S build, and these are two different things. So
right. Yeah.
the reality is you start planning and say, this is how my product looks like. Then you throw it over the wall, and the poor people in the factories would say, okay, how am I going to build this? Right. And then we're going to lose weeks and weeks, and you're going to have really sort of a lot of time lost and a lot of sort of efficiency lost being able to do this. We are reducing that. So our last factory we built, for example, was doing exactly that. We completely built it in the metaverse. So when we actually started producing, we could do this with a minimum effort and not all of this lost time is this machine doesn't fit here. Humans actually, we hadn't planned for them to actually do sort of continuous sort of movements. All of this can be sort of optimized up front in the metaverse, and you can actually show it to somebody who understands it. So what you've experienced on this loss between people which dream up products and people which build the products, we sort of took this barrier away.
Wow. That's enormous.
That's cool stuff, to be honest.
Yeah. Well, and then you go beyond that. So you've made that construction and commissioning and startup flow that much better. Now we get into production. What I'm hearing anyway, I'm not going to say you said it, but what I'm hearing is that you can also do optimization of the process before you ever get going.
Yeah. So I don't know. Have you read The Machine Which Changed the World? Right. I mean, the book on Japan, on lean, and the whole idea was there's a mistake. You stop the line and you try to find the mistake so you don't start producing bad quality. So that's the lean methodology. Now with digital, the world is different. The world is dramatically changing because what happens? Let's look at the battery process. It takes 3 weeks until you find out that a battery doesn't work. That means 3 weeks of production gets thrown away by the time you find out something doesn't work.
Wow.
What happened if you could combine this metaverse and the OT worlds to actually do this in real time to fix the problem? Give you an overview. In a battery production, just for you, you build a slurry and then you put it on a cathode and another node. And one of the biggest problems is residual humidity. So you have humidity, and it basically creates something which means the battery doesn't work as well or doesn't work as much. Now you could, because we have the PLC, we have the drive, with a camera, with infrared camera, we could see the residual actually humidity on the cathode. And with a laser, we can actually make it evaporate. So you fix the problem in real time at running at sort of quite a big speed at the same time. And this is only possible because you have a twin and you always say, what is the ideal situation? And you fix problems as they occur. You don't fix problem at the end of the process. And it's revolutionizing actually the way production works. And this is only possible because you combine the OT and the IT world.
Interesting. So we're going to take a break here real quickly, hear from our sponsor, DYS Media, and we will be back with Cedrik Neike here shortly.
DYS Media, your digital media relations agency. Public relations, website design, digital marketing. You get found by the customers and talent who need your solutions. You get media placements in top publications, the best job candidates coming to your website, a digital presence that gets you found by the right people. Call 616-298-8798 to get started today.
And we're back at Manufacturing Talks with Cedrik Neike at Siemens Digital Industries. He's been telling us some amazing stuff that has me just salivating for my next plant startup because he's going to solve all my problems up front and I'm just going to coast. Right, Cedrik?
I will try to help you as much as I can, but yes, definitely would want to help you.
So we were talking before we went out, some of those optimization measures that you can do in real time, optimizing the product and making sure it works right and that it's good going out the door. I actually wrote about it was GE Appliances that applies that, and it's more just in the size of some of their parts. They use 3D scanning and a heat map to show that their parts are meeting, what they were designed to look like and be from a size standpoint. It just seems like there's enormous opportunity in that quality realm of being able to compare what you're making with what it's supposed to be virtually, digitally, and like you talked about with batteries, literally save weeks of bad production, right?
Yeah, and you can fix, and the funny thing is, I mean, we're going into a world of a mass production of one, right? I mean, this is where we're going.
Yeah.
You want your car, you want your appliance, you want batteries perhaps a bit different. We want batteries to be similar, but there's these ideas that these need to happen. So if you go to most of a car factory today, of course, you have these gigafactories which produce only EVs or ICE type vehicles, but most of them on the same line would do an ICE, would do an EV, would mix and match the production of those elements and put all those capabilities in. With the digital environment, each one could have a digital twin just for you, and you check, is this actually the right quality, and is this actually working? So you this dream of mass production of one at costs, so having your unique product at a cost of mass production is actually coming much, much closer to reality, because you can actually have this digital twin of the product completely being compared to the digital twin of the production. And yeah, sorry.
Oh, I'm sorry. You just broke into a mental model I had, because I've heard about this so much in the 3D printing world,
Yes.
where clearly with 3D printing, you're sending a file to the printer and it's making whatever you want it to make. And now you're telling me we can get to that mass customization on what's essentially a standard production line today.
Yeah, and this is applicable to a lot of different areas. So one of the industries we've been working with is, for example, biopharmaceuticals. The idea is at the moment, I don't know if you know, so there's a lot of research to do medicine just for you. So cancer research is one of them. You would take a biopsy, you would take this biopsy, you would actually build an antidote based on mRNA, which actually would enable you to fight the cancer yourself. But this is just for you, and this is just based on those capabilities, and we need to do this at acceptable cost. So we would mass produce individual vaccines just for you. So that's another sort of industry it could be applied. We're working with the food and bath industry. The food and bath industry is going away from mass producing one type of ice cream and saying, look, do I want to have an ice cream just for you, or do I want to have faster changing ice cream capabilities? Same thing here. You need to sort of shorten the time between the recipe and the production, and we're working on that too. So this mass production is applicable to multiple industries, car industries, appliances, pharmaceuticals, and even sort of food and bath. And it starts to be really, really interesting to do that.
So I think this is going to circle us back to the Siemens accelerator. And that is, I'm putting myself in the shoes of a manufacturing guy on an existing floor today, running a business. What should that person be thinking about when it comes to all this? What are the transformations that existing manufacturers need to be aware of and be evaluating for their own business models, so that they're not getting left behind as we go into this bright, shining future?
And that's a good example. I mean, if COVID taught us anything, is that the companies which were digital and resilient and flexible survived COVID much, much better than the others, because you didn't know which semiconductor you would get. You didn't know, and you needed to sort of reprogram your production line to be able to build exactly what was available and what was needed. So my view here is you need to do two things. The first thing you need to do is to say, okay, what is my biggest problem in my production line, and can I use, perhaps from Accelerator, the right building blocks to solve that problem? But what you also need to do is, we've gone into a world where there's lots of little digital islands which don't talk to each other.
Yeah.
You never got the efficiency out of it. And the advantage of Accelerator, you can start tying these elements together. So you start somewhere, and then you build the next one and the next one, and you basically get efficiency by sort of putting these pearls, the string of pearls together, so that the data flows. We talk about digital threads. So my take is this: take your biggest problem, huge digital building blocks to solve it, but then think about what's the next problem, and how can you daisy chain them so that you really build not a lot of digital islands, but really a digital continent, if you want, something that works together.
Yep. Ecosystem is
An
the
ecosystem is a better word.
today.
Absolutely. Thank you.
You mentioned an important word that I absolutely wanted to cover. It was central to the article we had a couple of years ago, and I think it becomes even more central today, and that is data. We're all swimming in data, and what I'm hearing that Siemens is focused on is making data actionable for everyone out there.
Yeah, and I think last time when we talked about it, we're not only swimming in data, we're drowning in data.
Yeah.
I mean, if you think about it, an average Industry 4.0 factory produces 2.2 terabytes of data every month. That's 500,000 Netflix movies of data, and I think Netflix has 4,000 movies, and nobody watches all of them.
Right.
The question is how can you use this? And so the thing, and you talked about NVIDIA. So we work with NVIDIA, for example, to help build the metaverse, to make it look good, and how do we sort of fuse this data into a single model. Instead of having multiple digital twins, you have one digital twin. So that's one thing we do. The other thing we also do is a lot of this data needs to be actionable as close as possible to the production line. So what we do is we say, look, instead of taking these huge amount of data, putting it into the cloud, we're going to work on it on the edge. We will do the analysis, like I talked to you early on about the battery production. You see a mistake. This is visual inspection. You make the right decision. You reprogram the laser to do exactly what you want and solve this. So what we need to do is in order to do this actionability of the data, we need to understand where the data is most important in which context, and then apply the logic as close as possible to this context, and probably ideally with AI.
Right. Yeah. So there's ample future opportunity, is what I'm hearing.
Absolutely. And I'll give you, just a couple of things to make it real. So, for example, we're working with Daimler Truck. Daimler Truck has its own homegrown system on linking all of their R&D. They have Freightliner in the US, they have Mercedes-Benz in Germany, and they said, look, couldn't we build a single thread across this? And so we're helping them with the accelerator blocks so that something gets sort of invented in the US, it can be used in Europe, and it can be sort of followed up through it. So that's one example. Then we're helping Conti, for example, to automate all of their production lines so that when you have a model, you can actually automate this production line much faster, for example. So that's another example which you have. So if you're building tires, if you're building trucks, whatever you do, you start fusing this data to be able to make much faster decisions. And I'll give you a couple of hints, and we probably cannot talk about it before we do the press announcement. One of the press announcements we have is we will take our backbone of R&D, which is Teamcenter, our PLM. We will, with Microsoft, integrated with Teams, right? So, but the application we show is pretty cool. You will have somebody sitting in, I don't know, and in the other part of the world, in Japan, which will see on the production line a mistake, will talk. It's because not an IT specialist would talk what the issue is. We would do natural language translation. We will use ChatGPT to put this into the right blocks. And then by the time somebody looks at it, you have all of the quality defects categorized in the right environment. So you understand in your BOM where my quality issues are and why. So you start linking natural language translation, an open ecosystem, Teams and Teamcenter, and ChatGPT, OpenAI, to be able to solve those. And it's pretty cool stuff, to be very honest.
And it brings up another point that I was going to touch on, and that is, it's very possible that manufacturers, opportunities out there who are looking at this and looking, what's my first best move? It may have nothing to do with the factory floor, really, right? It might be business process, it might be design, and you're touching on all these elements.
Yeah, and that's the key point. Everybody might have a different starting point. As I said, look at your biggest issue, point one, but make sure that you have this as part of a strategy, a North Star, where you can start adding blocks so that these ties together. Yeah. The worst thing about the digital industries is we've been in POC hell, right? Everybody's done proof of concept. It works, but it's not scalable, etc., and it doesn't solve the problem. We need to go away, and we need to go into these MVPs, which you take the different blocks, you test it out, then you take the next blocks, you daisy chain them together, and then you solve either an ice cream issue on how to design a truck. You solve the issue that you have a efficiency problem on your factory shop floor. Problems might start from different points of view.
What about interoperability with existing systems? So everyone has that problem of, geez, I've got this legacy, whether it's an ERP or something out there, a PLC that's been around forever. Are your systems able to connect with older systems like that?
Yeah, we're trying definitely to have an open ecosystem, and backwards compatibility is super important in certain areas. And I mean, we work ERP, we have a strategic partnership with SAP to make sure that our software and the SAP software works together. When we look at somebody who wants to use AI and has NVIDIA technology, we work with NVIDIA, we work with Amazon. So we need to make sure that the ecosystem is open for external partners, but also for existing PLC and code which is there. And then bit by bit, you change the elements you have, because the reality is the brownfields are the majority of the investments which are out there. And we need to make sure that these brownfields get updated. And the way we do it is we build edge technology. So you would put an edge as close as possible to the machine or the line. It would collect all the data from legacy machines, translate it, and be able to action with IT, OT technology as close as possible to the existing production line.
Amazing. If you had to tell legacy manufacturers had a one overall point with all this that they need to be looking at and understanding, what would that be?
If you are not going to digitalize, i.e. your production, but also the data in the supply chains, you are going to be less and less relevant going forward. What we see is that most ecosystems, aerospace ecosystem, car manufacturing ecosystem, are digitalizing their value chains, all for multiple reasons. One, because it's easier to see where quality defects come from, but also because of reasons we haven't talked about it yet, which is sustainability. People will want to track that. So my view is if you're a small or medium sized producer, try to go at least digitalize some of the components so that you're part of this broader ecosystem. If not, you're going to be completely sort of cut out from the supply chains which are building up at the moment, which are going to be digitally very integrated.
You have had a magical ability here today, Cedrik, to anticipate what I'm going to ask you, because I was just thinking about the small and medium guys who, they may be still very manual on their shop floor. How much do you see that they'll need to automate production versus, automating business processes? Where does that fall for the smaller guys?
So it's one of the most important elements which is happening. So if you look at Siemens, we've been very successful on the large guys, mainly the auto manufacturers, mainly the aerospace industry, food and bev industry. And we made it our goal to see, and this is why we also built accelerators, how do we take this quite big technology and make it sort of in small chunks, which you could consume even over the cloud as SaaS, so that you can actually do this. So a lot of the accelerator elements is to make these elements smaller so you can digest them, and as much as possible also cloud-based, so you don't need to build your own IT system, you could actually do it. So my advice is, we are really trying to simplify the technology so it can be used, but please use it also, because that's going to be a competitive advantage for you going forward. And
so let me jump in there. Siemens, like you said, have been very successful with the big corporations. And what it sounds like is now where people may have been scared away just by the name because they're a small guy and Siemens doesn't apply to them. That's no longer true, right?
No, and our fastest growing part of the business is our SMBs, to be honest. And we see many SMBs actually upgrading. And the realignment of the supply chain, where a lot of it was actually built only in China, but is now going to be built in the US or built in Europe, means SMBs get a second chance to actually become bigger, right? I mean, become more important. And we are giving the tools and the technology to be able for those SMBs to do that. And we're trying to simplify it as much as possible, and also not make a lock-in. The whole idea of an open ecosystem is you can start with a couple of Siemens components. If you don't like other components, take those. But definitely we make them as easy as possible to digest and utilize and actually have an impact on your bottom line.
And reading through the materials up front, that was what leaped out to me, was reading about the accelerator and that modularity, because it is so huge. I mean, obviously, I'm out talking to manufacturers every day, and most of them are small and medium guys, because that's most of our manufacturers. So love that you're making your stuff relevant too. them and helping them understand the path forward.
And look, and manufacturing will take over the world. I mean, what's going to happen? And I'm just going to give you one other things we're going to show at Hannover Messe is we're going to show vertical farming. So one of my big aha moments was I went into an industrial park in Italy, but also in the US. And you come to this big wooden house and you come in and it smells of basil. Well, and you're like, oh my God, what is it? And it's a completely automated factory which produces high quality lettuce, for example, or basil, and it uses very little water, nearly no water. It uses very little energy. It takes CO2, and it has, in the case of Italy, it had the quality of 3-star restaurants, so it really tasted well. So this technology, which came out of which is a complete automation of it. There's no human. I mean, there's 6 humans for 300 hectares of production. It basically means the technology we're just discussing is for manufacturing, classical manufacturing as we understand it, but also for new industries like agriculture. So your mango can come from a place which is just next to you. It doesn't have to travel half the world, and it actually tastes well because it hasn't been shipped for weeks and weeks. So there's a couple of cool things we're really also working on for the next level.
Amazing stuff. Well, I would love to talk all day, but I can't take all your time, Cedrik. I know you got things to do, but to wrap up, what do you want to leave people with that Siemens Digital Industries is after here?
Yeah, I mean, the main idea is I think we are at the cusp of something amazing, right? I mean, I think that we have with industrial technology for the first time the chance to really have an impact on society, right? We can, if you don't find enough people, automate. We can have an impact on the environment because we can produce more efficiently, and we can have an impact on your bottom line. And please embrace it. As I said, we've been talking about digital. It's happening now. And COVID has shown that if you're digital, you can react and thrive in much more difficult environments. And we're definitely going to be in very changing and difficult environments. So this is a good solution, and I would love for people to adopt it. It's
very exciting stuff. Folks, do not be scared away by the term metaverse. This is the good metaverse. But yeah, all my small and medium friends out there, check out Siemens. They have things to offer you. Cedrik, it has been an absolute delight talking to you. Thanks for all the information. And Jim, like always, absolute pleasure. And thank you so much. And looking forward to see you again. Same here. And bye-bye. Thanks to all of you for tuning in to Manufacturing Talks. And I'm pleased to announce that we are now going weekly. So tune in every Tuesday. We'll have a new episode. I can't promise everyone's going to be as thrilling as this one with Cedrik, but they're going to be good. So tune in. Definitely. Thank you. Thanks, Jim.
Thanks for tuning in to Manufacturing Talks with Jim Vinosky. Watch for new episodes dropping every Tuesday. And don't forget to like, share, comment, and subscribe.